Imagine, if you will, a second Earth forming in our solar system. Could it be possible? Picture it. A cosmic ballet where space dust and rock pirouette in the void, gradually coalescing into a celestial sphere. The asteroid belt, a vast ring of rubble encircling our sun, perhaps a cradle for a new world. This is not mere idle speculation. The seeds of planets, they say, lie in these rocky fields. As we journey through the frontier of space, we're confronted with fascinating possibilities. Could the same process that birthed our own blue planet be happening in the asteroid belt? Could this seemingly desolate region actually be a planetary construction site? The idea is as intriguing as it is awe-inspiring. A second Earth, born not from the primordial nebula that formed our solar system, but from the lonely asteroids circling our sun. In the vast expanse of space, could the asteroid belt hold the potential for such an extraordinary event? The asteroid belt, a region of space filled with millions of celestial bodies, could it be the birthplace of a second Earth? Imagine, if you will, a band of cosmic rubble strewn between the orbits of Mars and Jupiter. This is our asteroid belt, a celestial junkyard, if you will, but one that may hold the key to an extraordinary possibility. Let's start by discussing the asteroid belt's basic structure and composition. It's a vast, donut-shaped region that's home to millions, if not billions, of asteroids. These space rocks range in size from tiny pebbles to objects hundreds of kilometers in diameter, and they're made up of a wide variety of materials. Some are rocky, others are metallic, and a few even contain water ice. These asteroids are not just randomly scattered either. They're organized in a sort of cosmic dance, each following its own elliptical orbit around the sun. This dance is dictated by the laws of gravity and the influence of Jupiter's massive gravitational field. Now, consider the mass of the asteroid belt. Although it contains countless objects, the total mass of the entire belt is thought to be just a fraction of the Earth's. If we were to lump all the asteroids together, we wouldn't even get a planet as large as our moon. But what about the materials these asteroids are made of? Could they contribute to the formation of a planet? Well, asteroids are like time capsules from the early solar system. They contain the same basic building blocks that formed the planets. So in theory, these space rocks could come together to form a new planet. However, there's a catch. The asteroids in the belt are moving at high speeds and in different directions. For them to come together and form a planet, they would need to slow down and start moving in the same direction. This would require a massive external force, something that's currently beyond our technological capabilities. But the question remains, do these space rocks have the capacity to come together to form a planet? Well, with our current understanding of the universe and the laws of physics, it seems unlikely. But who knows what the future may hold? After all, the universe is full of surprises. To answer this, we need to understand the science behind planet formation. And so, our journey through the cosmos brings us to the fascinating world of planet formation. It's not a process that happens overnight, but rather, it's a dance that unfolds over millions and billions of years, choreographed by the laws of physics. Let's start with the concept of accretion. Picture, if you will, a vast, cold, and mostly empty space. In this space, particles of dust and ice, remnants of the birth of a star, begin to collide and stick together. This is accretion, the first step in the formation of a planet. Over time, these tiny particles grow into larger and larger clumps, or planetesimals, which continue to collide and merge, growing ever larger. Then comes the gravitational pull. As these planetesimals grow, they exert a stronger gravitational force, pulling in more and more material from their surroundings. This process is self-perpetuating. The larger the object, the stronger its gravity and the more material it can attract. Eventually, this leads to the formation of a protoplanet, a large body that is on its way to becoming a fully fledged planet. However, not just any clump of matter can become a planet. There are specific conditions required. For one, the object needs to be large enough to have sufficient gravity to shape itself into a sphere. Additionally, it must clear its orbit of other debris, becoming the dominant gravitational force in its vicinity. These are the criteria set by the International Astronomical Union, the governing body that defines what is and isn't a planet. So why is this important? Well, if we're to speculate about the asteroid belt forming a second Earth, we need to consider these processes and conditions. Can the asteroid belt accumulate enough material through accretion to form a protoplanet? Does it have the potential to exert enough gravitational force to clear its orbit of other debris? With this understanding, we can now examine the likelihood of a second Earth forming from the asteroid belt. After considering the asteroid belt's composition and the science of planet formation, can we expect a second Earth to form? A tantalizing question, certainly. But before we let our imaginations run wild, let's see what science has to say about this. Firstly, the total mass of the asteroid belt. It's easy to picture the asteroid belt as a dense, chaotic field of space rocks. But in reality, the total mass of all the asteroids combined is surprisingly small. If we were to bunch them all together, the result would be a celestial body only about 4% the size of our moon. That's far too small to form a planet, let alone a second Earth. Secondly, the gravitational pull of Jupiter. Jupiter, the largest planet in our solar system, has a significant gravitational influence on the asteroids in the belt. This gravitational pull keeps the asteroids in their orbits, preventing them from accreting or coming together to form a larger body. This is the primary reason why the asteroid belt, despite being around for billions of years, has never coalesced into a planet. Now let's consider the composition of the asteroids. The asteroids in the belt are made up of a mix of rock and metal, similar to Earth's crust and core. However, they lack the necessary volatiles, elements like hydrogen, helium, and other gases that are essential for the formation of an Earth-like atmosphere. Without these, even if an asteroid planet were to form, it would be a barren, inhospitable place, quite unlike the Earth we know and love. So can we expect a second Earth to form from the asteroid belt? The current understanding of planetary science suggests that it's highly unlikely. The mass, the gravitational influences, and the composition of the asteroids all present significant obstacles. While the idea of a second Earth is intriguing, science tells us it remains a fascinating impossibility. But who knows what mysteries the universe still holds for us to uncover? The vastness of space holds many wonders, and the possibility of a second Earth forming from the asteroid belt is an intriguing concept. We've journeyed through the space frontier, considered the asteroid belt as a factory for a second Earth, delved into the science of planet formation, and speculated on the existence of a second Earth. The asteroid belt, with its diverse and numerous celestial bodies, has captivated our imagination. Yet the scientific consensus suggests that the formation of a second Earth from these scattered fragments is rather improbable, given our current understanding of physics and planetary formation. The collective mass of the belt is too minute, and the gravitational forces not quite sufficient to coalesce into a planet the size of Earth. So while the notion of a second Earth conjured from the asteroid belt sparks fascination, it remains, for now, a tantalizing conjecture. In the realm of space, the impossible can become possible, and the possible can become impossible. The universe is full of endless possibilities, and all we can do is explore and wonder.